when we talk about ARQ protocols, we define stop and wait, and we define the continuous ARQ protocols. In specific, we define the go back N and selective repeat. Now, let's go and check the stop and wait protocol. The idea behind the stop and wait protocol, as the name suggests, is that the sender A sends an information unit to the receiver B, and only once the information unit has been received, then the receiver B will send an acknowledgement message to the sender A. So, as the name suggests, is stop and wait. So, once A in fact has sent an information unit, it stops until it has received an acknowledgement from B. In fact, this is also what is explained, that the acknowledgement and the timeout happens in such a way that the transmitter A triggers the timeout once transmitting. The idea is that when the information unit is sent out from A, it's waiting for an acknowledgement, but in the moment that it has transmitted it, there is also a timeout in place, which allows to somewhat keep track if the acknowledgement has been received in time. In fact, if the timeout will expire before receiving the acknowledgement, then the transmitter A will retransmit the same packet. Let's look at an example. Here we see a transmitter and a receiver. We have packet number 1, which is sent from the TX towards RX. Once the packet has been successfully accepted, received, then the receiver RX will send an acknowledgement message towards the transmitter TX. So this acknowledgement message is sent out to the transmitter TX. Only once the TX, the transmitter, has received the acknowledgement, it may proceed with the transmission of the second packet. In fact, if when the second packet is transmitted, there is some error in transmission, the transmitter TX will wait a defined time, which we call timeout, before it retransmits the packet. In this case, this can be interpreted as the fact that the transmitter has not received an acknowledgement within the time frame defined as timeout. Of course, once the packet is retransmitted and then again acknowledged, the transmitter can proceed with the transmission of the third packet. In order to have all of these mechanisms in place, it is necessary to have a 1-bit numbering that basically enables to discard packet segments data that is duplicated. Since we're talking about the transport layer, of course, we're always referring to segments. So, question to be answered is how long this timeout should last, because you don't want to be too inefficient in the way how you implement the transport layer protocols. In fact, it should not be large enough because it could make that the communication is not very efficient. So the minimum timeout value which is defined is TAC plus 2 tau. In this case, the TAC is the transmission time of the acknowledgement message, and the tau is the propagation time. We have here in the formula 2 tau because we have the propagation time from the transmitter to the receiver, which is 1 tau, and we also have the propagation time from the receiver to the transmitter, which is again tau. Therefore, the minimum value of the timeout is defined as TAC plus 2 tau. In fact, we can also define what is the efficiency of the stop and wait protocol. In a similar example as the one we saw before, we have the transmitter, we have the receiver, we have the data that needs to be transmitted. This data which is transmitted has a certain transmission time t. It is characterized by a certain propagation time tau, and this propagation time is the time it takes to transmit the data from the transmitter to the receiver. And of course, there is the TARQ, which is the transmission time of the acknowledgement message. Hence, we can define the efficiency of the stop and wait protocol as the ratio between t and t plus TARQ plus 2 tau. Again, to clarify, the t refers to the transmission time of the data itself. The tau refers to the propagation time between transmitter-receiver and receiver-transmitter. And the TARQ is, as defined in the previous slide, the transmission time of the acknowledgement message. And hence, eta here represents the efficiency of the stop and wait protocol.